Hello everyone. So here today I will talk about problems for the variable control chart. The first problem is that we have the bulb manufacturer that manufactures the car headlight bulbs, and so they are manufacturing thousands of car bulbs, so lots of them. To know whether the process is under statistical control, so what we do is that we take 15 samples from the headlight bulbs, and then each of them has a size of 4. And they are the regular intervals. We are using the regular intervals. And then we are trying to understand what is the lifetime of the headlight bulbs. So what's happening is that we have the assembly of the light bulb manufacturing, and then we take 15 samples, and then each sample contains 4 headlights. So overall we have the 60 headlights for test. Okay, this is not the whole population, this is just part of the population. And then for this part of the population, we are trying to understand these 2 questions. The first one is that, so we will try to find the population mean. So what it means is that here it is the lifetime. The lifetime, average lifetime, let's see. Average lifetime of the whole set of the light bulbs using 95 confidence interval. So it means that you are confident. So 95% confident, or you can say that the certain. So you are 95% certain that the population mean will be in this range. So that is the question for the first part we will answer. The second part will be that we have to determine whether the process of this manufacturing headlights are under control or not. What means is that, is there any headlight? So this is a question, you know, that this is just asking that any headlight out of range. Okay, so to know whether it is out of range or not, so you have to draw the Xbar and the R chart. So when we are done with the Xbar and the R chart, we can answer the question of whether the process is under control or not. This is the second part of the question. So these are the samples. We have the sample 1 up to 15. As the question says, we have 15 samples. And then each sample contains 3 light bulbs. So we have the sample 1, we have sample 2, so up to we have the sample 15. And then each sample contains 3 of them, so we can say that this one is the sample size. Sample size, we say that n, and n is 3. And then one more thing here is that instead of sample, you can say also the subgroup. The sample and the subgroup, they are the same concept. So let's firstly try with the first one. So we are trying to find what is the population average lifetime. The population, as I said, it is the all bulbs. So this is not just not 60. Okay, this is not 60, as the question says that these are thousands. So it means that, so this one is the thousands. So we are trying to understand what is the average lifetime of the whole light bulbs. Okay, this is the first part of the question. So this one, I will call it as a mu. Okay, then I will use the formula from the previous lectures is that mu is equal to that the grand average. This one is the grand average, or you can say that the average of averages. The average of averages. So then plus minus, we will have the T alpha by 2, and this one, so in Excel, I will find it, and then times the S. S will be the standard deviation of all data. Let's say sample data. And then divided by the square root of n. And then n is 3 here. So we have set the value of the n is 3. So you can see 1, 2, 3. We have 3 sample, 3 bulb in each sample. The sample size is 3. So this one we can just say here it's the 3. So we will determine the value here, the x double bar, or you can say grand average. Then alpha by 2, this one is by Excel, and then S again. So this one, I will use Excel to find what is the value of the X. So let's do that, and then we can move the next part of the question. So okay, so these are the data that we have, the same data that is in the Excel. Okay. And then for this data, first I need to find the grand average. So to find the grand average, I will need to first find the X bar. And the X bar is the average of each sample. So I will take the average of each of my sample. Okay. And then similarly, this one you can see is the average of these 3 values, the first sample. So I will take the average of the second sample as well. So I can just do this, and then you can see this one is the average of the second sample, the average of the fourth one, average of the 10th sample. So this way I have the X bar, and then X, the double bar, or you can say the grand average. They are the same stuff. So that will be the average of average. So I will take the average of this whole average, okay, which is 900.2. So I am done with the X double bar. This one is finished. Second one is the standard deviation, so the S. To find the standard deviation, I will just go into the standard deviation of the samples. You can see the first one is the population, but in my case, it is sample. So I will use the sample, the second one, and then select all the data that I have. So this one is 179, the standard deviation of the sample. So the last thing is the T alpha by 2, and that one question says that it should be with the 95% confidence interval. So T alpha by 2 by 95%. So I will just use the T inverse in Excel. And this is just the T distribution, T student distribution. So it has 2 parts for me. The first one is the probability. The probability is just the 1 minus 95. So 1 minus 0.95. This is the first one. The second one asks the degree of freedom. The degree of freedom is just n minus 1. So it will be 2. Okay, let me write it here. So in Excel, it will ask the 2 things for me. The first thing is that, so this one is Excel, so you will use T inverse. The first one is the 1 minus 0.95. The second one is the degree of freedom. And then this degree of freedom will be that n minus 1. So the n is here 3, and then n minus 1 will be 2. So 0.05, and then we will have the 2. So this one is done. So this is the, so let's now put all together formula. So mean will be that. So I will just find the second part. So T alpha by 2, which is this one, times the S value, which is this one, and then divide by the square root of n. So square root of 3. Okay, 445. So the result says that the mu value will be equal to this one by Excel, it is 900.2. So 900.2 plus minus 445. So since the given values here are up to 3 significant digits and we don't have any decimal point, so I will not use anything here. So 900 plus minus 445. Okay, and then this value is large. So because the 95 confidence is big. So you are saying essentially that I am 95% sure that the average lifespan of the car headlights are in this range. Since the confidence level is high, then the interval is also high. Okay, if you just go lower confidence, say that I'm not confident, for example, I'm in the 30s, 30% or 40%, then the value will drop. As your confidence becomes higher and higher, then you are giving a larger range because it should be there because it's very high confidence. It should be there, therefore the range should be bigger so that you are always right. Okay. This is the first part of the question. The second part of the question says that determine whether the process is under control or not. So let's do that one. So for this one, I will use the chart that we had from our previous lecture. Same chart here. And then for this one, let's go to Excel again and then start with the Xbar chart. So since we have the Xbar, so I will first need to find the A2 value because if you remember from our previous lecture, we said that for Xbar chart, so we need to find the X double bar plus minus the A2 value times the average range. And then for R chart, so we said that we have to find the 3 times R bar and then the 4 times R bar. And then A2, D3, D4, so we have the A2, and then we have the D3, we have D4. We are all looking for the value of 3 because n value is 3. Okay, this is what we are looking for. So A value is 2, this is the first one, and then D3 is 0, and then D4 is this one. Okay. Now the time is to start with these values and then plot the X bar and then to see, I mean, the question is that the process is under control or not. So is there any variation in the process? You can see the variation here. Let me just add another color. So we have variation in the lifetime of bulbs. Because we have said, you know, you don't have a identical part. So the part that you have, even the same company, they have the different range of qualities. So we have variation. It's not all headlight bulbs are not the same. So that is the issue here. We have variation. The question is that, is this variation, is this one under control or not? So are we controlling the variation, or the variation in the process is in a way that the lifetime of the bulbs are more than random. So it means that you cannot control the variation. Any value may come out. But this is the main question that we are trying to answer. Can we control the variation here? Is it under control or not? We cannot know for sure because you have to use the statistics. Okay, you cannot just look at it and say that, okay, this one is low, this is under control. No, you have to use the statistical tools and then try to understand if it is under control or not. Okay, so then A2 value, as I said, from the chart for n is 3 is 1.023. And then the grand average is that the average of the Xbar values. This is the grand average because we are looking for the Xbar plus minus A2 times the average range. The R bar is, this one is the average range. So average range means that firstly I need to find the range, then I can find the average of it. So first the range. The range is just the maximum of the sample values minus the minimum of the sample values. Okay, and then if I just drop down, you can see these are the range values. Okay, let me just copy and paste it here. And then average range will be that the average of the whole range values. Okay, so you see I found the maximum of the sample minus the minimum. So here also maximum minus minimum, the maximum and the minimum. So this way I have found the range, and then I have found the average range. So you can see this one is the average range. Now so since we are trying to find X, this one, so we are trying to find this part. So if I write it here, the upper control limit is X plus A2 times R. The lower control limit is this one minus A2 times R. This one is for X bar chart. For the R chart, the upper control limit is the 4 times R bar. Lower control limit is the D3 times R bar. This is the R chart. Okay, so this is our aim for R chart, and this is our aim for the X bar chart. Okay, so since we have the grand average, we have the A2 value. Now time to find is the upper control limit. Upper control limit is the average plus grand average. A2 times the R value, average R, you can see this one. And then all of the values should be in $sign because we will use the same one for whole column. Okay. And then similarly, I will do the lower control limit. And lower control limit is the same formula, but just you have the subtraction here instead of multiplication, I mean the addition. So this one is subtracted, okay? And this is the lower control limit. This is upper control limit. This is one for X bar chart. And this one is for, again, X bar chart. And then we will have the grand average. Okay, and then this one will be equal to this one here, again with the $sign. And then this part is done. Now let's plot it and to see if everything is under control or not. Okay, so let's select the data. So first is that the X values are just the samples. The Y values are the average X bar values, these ones. Okay, let me edit it. So the x values, are the sample numbers, and then y values are the average values. Okay, and this is the average of each sample, but I need let me just add a line here. Okay, but I need the upper control limit and the lower control limit to see if my data is under control or not. So then we are adding the y values. X values are the same, therefore I will not select the x values. They are the same. No need to select again. Then add the lower control limit. Sorry. Let me just add again the y values, the lower control limit. Okay, and then let's add the final, the grand average. Okay, so let me just format this one, make a solid line, and this one as well as solid line. So you can see the data that we have, the data, this is under control. You can see the upper control limit is here, and we don't have any value more than that, and we don't have any value less than the lower control limit. So X bar chart shows that the average of our values, the average, we are dealing with the average values are under control. So this is the what X bar the data shows. And now comes the R chart, the second one, the second part of the question, that because we cannot just go with this one, you know, we need to look both together. So this one and that one together. And then let's look for the R chart. The R chart will be similar to X bar chart. The only difference is that, so the upper control limit is D4 times R bar. The lower control limit is D3 times R bar. So let's do that. And so this one is for the, so now upper control limit for R chart and lower control limit for the R chart. And then we need to write the D3 value, and then we need to write D4 value. D3 value from the chart, it is 0, and then D4 value is 2.574. So D3 is 0, D4 is 2.574. Okay. Then upper control limit for the R chart will be the D4, this one, times the R bar, the average range. This is R bar, okay? And then this one should be in dollar sign because we are using it for whole solid line. And then done. The lower control limit is the similar, that will be D3, this one, times the average range. Again, the same formula, but only D3 changes. Okay. Now the time is to plot them. So let's do that and then insert plot. Insert the plot. Let me erase whatever is there. Okay, so first, let's select the data. The X values are the sample. The Y values are the range data. You can see the range values. Now we are looking, in the previous case, we looked at the average values. Now we are looking the range values, how the range changes, because range gives us the maximum and the minimum. Okay, and then let's add the upper control limit. For this one, we are selecting the same, the X values, therefore I will not touch. The Y values will be lower control limit. Okay, and then I will add the upper control limit. Okay, and then I will add the, okay, that's all. So you can see that the range values, they are also in the, they are not greater than upper control limit. They are not less than lower control limit. It means that the process is under control. So you can add the average range as well to see average range where it is located. So R bar, it will be the average range here. You can add again F4. Okay, and then add the average range here. Select data, and then X values is the same. The value values is here. You can see the range values are located around the average. Let me just format this one. Okay. So this is this one shows that the process is under control again. So let me go back to PowerPoint, and this is the first chart from the X bar. The same, yes, I just formatted, yeah, X bar chart. As you can see, the average of my first sample, the second sample, all of the samples are in this, that is in control. You can see the process is under control. However, we have variation. So that's true that we have variation. So I should say it, reiterate it again, that every process has variation. So there is not any process that doesn't have variation. As you can see, however, we have the variation, every manufacturing process has variation. And then however we have the variation, you can see it is under the control. It is less than upper control limit. This is UCL. And this is greater than the lower control limit. This is what X bar chart shows. But X bar chart is not always enough, as I told. We need the range chart as well. Let me say you this, yeah. This X bar chart, this one compares the average of each sample. The average of each sample. So for example, the sample 1 average compares with the sample 2 average, compares with sample 3 average. So this one, we are trying to see how the averages change. So no problem. Now comes the X bar chart. I mean the R chart. For the R chart, you can see this one is R chart. It is again under control. Same graph in Excel. This is the same one. The same one. It is under control. We don't have anything. So again, under control. So the R chart, it compares the max and the minimum of the samples. So as you can see, the maximum and the minimum data we have for each variation, it shows that there is no any problem. As I said, every process in manufacturing, it has variation. There is no any process that there is no any variation. Every process has variation. However, we have variation, it is under control. You can see it is under the limits of the control. That is what we are looking for. So under you can say statistical control. Okay. So this is the final graphs to both of them. Okay, now I will look for the, let me